Besides the method parameters, there's one other way that we can customize the methods that we write. So far, all of the methods that we've used have been void type methods, or had a return type of void. This basically means that those methods return no values back to us. However, we can write methods that return back values that we can utilize to do whatever we want them to do. Let's complete an example. Let's say we need a method named takeDamage, where we'll pass in the amount of damage that a character takes. That damage will then be subtracted from the character's health, and then the method will return back a true or a false. A value of true means that the character is still alive. A value of false means the character has been defeated. I'll start by declaring an integer for the health and set it equal to 10. Next, I'm going to declare a public variable called DamageToTake, which will allow me in the inspector to specify how much damage the character should take. It's generally good practice to put our public variables at the top, regardless of the order that we write them in. So let's fix that now. Now we can create our takeDamage method. Normally we would write void to start our method declaration. However, this method is not the void type of method. Void, again, means it doesn't return a value, and we want it to return a value. We want it to return a Boolean value. So we are going to use the keyword bool to specify the data type that it returns. Then we're going to type its name, in this case, takeDamage, followed by any parameters that we might need. In this case, we are going to read in an integer called amount. That is going to be the amount of damage the character is going to take. Inside this method, we are simply going to take health and subtract from it the amount of damage. If health is still greater than 0, we're going to return true. If it's not, we're going to return false, again denoting that the character has been defeated. We return a value with the return keyword. We can't return a value out of a method without the return keyword. However, it's worth noting that return does not always need to return a value. In the case of void methods, return simply leaves the method without returning anything at all. So if I wanted to skip some code inside start, I could simply type return. Then anything that happened after that return statement wouldn't be executed. It would be silly of us to do that now though. Mostly I just wanted to show that to you. We can see that if our health is greater than 0, we're going to return true. However, if I were to just save this now, I would have an error. The error says, not all code paths return a value. Let's go back to our method and take a look at why we got that error. If we look at the code, we can see line 16 subtracts amount from health. Line 17 says, if health is greater than 0, return true. But then what happens if health is not greater than 0? You can see we don't return any value in that instance. Therefore, we have an error. All code paths, or all branches of a branching logic structure like a conditional if statement, must return something. So we can simply say, if health is greater than 0, return true, else return false. Now, since we know the return keyword returns a value immediately and any code after it will not be executed, we can actually even shorthand this another way. We don't really need that else statement, because if the if statement is true, we'll return directly out of this method right then and there. Otherwise we won't. So we can shorthand this to look just like this. Now, if health is greater than 0, we return true. Otherwise, any other branches, we return false. If I go back to Unity, I'll see that my error has now gone away. Now this is all well and good, but we still need to actually call this method and utilize its value. Inside start, I'm going to create a Boolean variable called result and set it equal to the method takeDamage. I'm going to pass into takeDamage our global variable DamageToTake. You might be thinking that it seems silly to pass DamageToTake in as a parameter to the takeDamage method, since we could simply use it inside the takeDamage method because it's a global variable. You would be correct, we're simply doing this as a means of an example. In a real situation, take damage might be called by some enemy class or some projectile like a bullet or a grenade or a paintball or anything like that. We're simply keeping this contained to a single class for the purpose of demonstration. The last thing we're going to do is we're going to output result to the log so we can see if, given the current damage to take, if the character is defeated or not. We can go back to Unity and try this out. We'll see that if we only make the character take 5 points of damage, they remain alive. They are not defeated. However, if we increase the damage they're going to take to, say, 20, and then run it again, we will see now that 20 damage is enough to defeat them.